Oftentimes, we don't find the exact resistances we want. So this makes us to have to learn to sum up resistances. There are two basic resistance arrangements you could have. The first is the series arrangement, and the second is the parallel arrangement. Every other arrangement follows the combination of these two in one form or the other. So let's discuss the series arrangement. In the series arrangement, you have resistors connected end to end. So you have one resistor connected to another resistor, connected to another resistor, and so on. So let's call this R1, R2, and R3. For this, simple calculation for your resistance is your total resistance is equal to the summation of the values of resistor 1 plus resistor 2 plus resistor 3. As simple as that. Next, let's look at your parallel arrangement. In your parallel arrangement, you have resistors connected like this. Let's say this is one resistor, the next resistor is connected to it like this, the next one connected, and so on like that. The formula used to calculate this is, if this is your R1, R2, and R3, the formula used to calculate it is 1 over total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on like that. So let's look at 4 examples. So the first example is going to be a simple series circuit. Example 1. So find the resistance when you have 3 resistors connected in series of 1 ohm, 1 ohm, and 1 ohm each. The solution to this is going to be 1 ohm plus 1 ohm plus 1 ohm, which is equal to 3 ohms. Now let's go to example 2. Find the total resistance if you have 2 resistors of 2 ohms each connected in parallel. One thing you should always note about parallel connections is that your total resistance can never be higher than the smallest resistance in that parallel circuit. Now take a look at this. 1 over total resistance is equal to 1 over 2 ohms plus 1 over 2 ohms. Half plus half is equal to 1. So this is 1 over RT is equal to 1. If you cross multiply, you find out that RT is equal to 1 ohm. So you can see 1 ohm is not higher than any of this. So if you have 2 resistors of equal value in parallel, they would form half of one of that resistor. Well, if they have different values, your total resistance can never equal or be greater than the smallest resistance you have in that parallel circuit. Let's take another example of a parallel resistance. Example 3. So here we have 2 ohms and here we have 4 ohms. 1 over total resistance is equal to 1 over 2 plus 1 over 4. So this is half plus quarter, which is equal to 1 over total resistance equal to 3 over 4. That means RT is equal to 4 over 3, which is equal to 0.75 ohms. You can see it's less than your smallest resistance there. Then the third example we are going to do is going to be a combination of a series and a parallel circuit. So you have example 4 here. Example 4. So this is going to be 2 ohms, 2 ohms, 2 ohms, and 2 ohms. First of all, I'm going to solve for the resistance here. Solving for the resistance in this part, we have 1 over RT equal to 1 over 2 plus 1 over 2. We solve that here, and that gives us 1 ohm. So RT here is equal to 1 ohm. So our circuit becomes equivalent to this: 2 ohms, 1 ohm, 2 ohms. So our total resistance here is equal to 2 plus 1 plus 2, which is equal to 5 ohms. Then the last example we'll take is what if the arrangement, how do you know when it's parallel or series? You just need to rearrange the circuit to make it much more understandable. So I'm going to do this. The question says circuit like this. So we have 2 ohms here, we have 2 ohms here, 2 ohms here, 1 ohm here, .5 ohm here. Now this might look complex, but let's take it one at a time. If I redraw this, I'll have a circuit that looks like this. This resistor, pulling out, I have this other resistor, this other resistor. This resistor is connected in parallel to this. This is connected in parallel to the whole of this. And this is what I have: 2 ohms, 1 ohm, 2 ohms, 2 ohms, 0.5 ohms. So solving this here, we can see it's the same as this part here. So this is going to give me 1 ohm. So here I have 2 ohms, 1 ohm, 1 ohm, 0.5 ohm. Summing this together, I have 2 ohms here, 2 ohms with 2 ohms here, and 0.5 ohms here. Let me redraw that. 2 ohms, 2 ohms, 0.5 ohms. These two are in parallel. You have 1 over RT is equal to 1 over 2 plus 1 over 0.5. So we have 1 over RT is equal to 1 over 2 plus 2 over 1. And this is equal to 5 over 2. Therefore, RT is equal to 2 over 5. Which is equal to 0.4 ohm. So we have 2 ohms in series with 0.4 ohm, and this totally gives us 2.4 ohms. More resistances can be added together in this form in more complex manners, but this is the basics. I hope you enjoyed the video you just watched. If you liked it, don't forget to like and subscribe. This is Ellison. Bye for now.